Hello, everybody. In Module 1, I provide introduction to theory, discuss traditional models of capital markets, and explore how disclosure affects various capital market outcomes. Module 1 has 6 lessons. Today, we're focusing on lesson 6, Discrete Kyle model, and how disclosure affects liquidity in various Kyle-type models. First, let's briefly discuss how disclosure affects liquidity in continuous order flow Kyle models that we discussed in the previous lesson. In the previous lesson, we discussed the continuous order flow Kyle model. We derived the expression of lambda as a measure of illiquidity. So if more precise public disclosure is modeled as an increase in prior precision, then more precise public disclosure by decreasing sigma 0, which is the prior variance of the fundamental, decreases lambda and increases liquidity. We can also show that if more precise public disclosure is modeled as an increase in the precision of exposed signal about the fundamental, then more precise public disclosure also improves liquidity. The reason is that regardless of whether more precise public disclosure increases prior or posterior precision, it reduces information asymmetry between the informed trader and the market maker. Such information asymmetry gives rise to illiquidity, as we discussed in the previous lesson. In an extreme case, when the disclosure is perfect, then there is no information asymmetry and illiquidity disappears. Now we're going to switch gear and talk about discrete order flow Kyle model. Why? Because the continuous order flow Kyle model may be intractable if we add more ingredients. For example, the feedback effect that we're going to discuss in the next module. In addition, essential feature in the Kyle model of continuous order flow is going to be preserved. The essential feature in the continuous order flow Kyle model is that there is information asymmetry between the informed trader and the uninformed market maker. And so the market maker is going to price protect himself or herself, resulting in price moving against the informed trader's trade. We're going to see such features are preserved under discrete order flow. In addition, the bid-ask spread naturally arises. So now let's look at the setup of a discrete order flow Kyle model. The terminal payoff of the risky assets denoted as V, instead of being continuously distributed, it's binary now. V is either 0 or 1. The prior probability V equals 0 is 1/2. Let's assume there is one noisy trader. The noisy trader can either sell one share, no trade, or buy one share with equal probability, which means each event occurs with probability 1/3. We assume potentially there is an informed trader that observes V and can either buy or sell at most one share. This can be justified based on cost considerations. You cannot trade infinite amount of shares. Why we are saying potentially informed trader? Because we assume for some exogenous reasons, the informed trader may not appear in the market. The informed trader only appears in the market with probability P, which means with probability 1 minus P, there is no informed trader. So there is 0 order flow coming from informed trader in this case. As in the continuous order flow Kyle model, the market maker observes the total order flow, which is the sum of the informed trader's order flow and the noisy trader's order flow. And it chooses price P is equal to expectation of V conditional on the order flow and the conjecture of informed trader's trading strategy. So to solve the model, again, the market maker needs to conjecture the informed trader's trading strategy. Recall that in the continuous order flow Kyle model, the informed trader is going to buy if V is bigger than the prior mean. It's going to sell if V is smaller than the prior mean. Because in this model, the prior mean of V is 1/2. So the conjecture is that informed trader is going to buy one share when observing 1, and it's going to sell one share when observing 0. Of course, this conjecture has to be consistent with the actual choice. So you need to eventually verify this is the case. We're going to skip this in this lesson and leave that for you as an exercise. The market maker, again, needs to set the price as a function of order flow for each possible realizations of order flow, taking into account the informed trader's trading strategy. That means when S equals +2, the order flow is fully revealing the informed trader buys, because if the informed trader does not trade or sells, the total order flow cannot be +2. So the market maker will set price equals 1 when order flow is +2. Similarly, when order flow is -2, the market maker is going to set price to be 0 because it's fully revealing that informed trader sells. And for the other order flow realizations, -1, 0, or +1, the market maker needs to use Bayes' rule to figure out the expectation of V, because V is exogenous. Because V is just 1 or 0 in this case. So to figure out expectation of V, it is sufficient to figure out the probability of V equals 1 conditional on the order flow. The Bayes' rule derivation shows that in order to derive the probability of V equals 1 conditional on S, we need to know probability S conditional on V equals 1 and the probability S conditional on V equals 0. Let's use S equals +1 as an example. When S equals +1, the probability S equals +1 conditional on V equals 1 is 1/3. How do we get that number? Conditional on V equals 1, S equals +1 is possible only under 2 cases. The first case is that the informed trader is present. The informed trader buys because V equals 1, and the informed trader observes V equals 1. And the noise trader does not trade. This happens with probability as the product of the probability that the informed trader is present, which is P, and the probability that the noise trader does not trade, which happens with probability 1/3. So this case has a probability P/3. The second case is when the informed trader is not present. So 0 order flow from the informed trader. The noise trader buys 1 share. This happens with probability as the product of the probability that the informed trader is not present, 1 minus P, times the probability that the noise trader trades 1 share, 1/3. So the second case occurs with probability 1 minus P/3. So the probability of S equals +1 conditional on V equals 1 is the sum of those 2 probabilities, equals 1/3. Now, conditional on V equals 0, probability S equals +1 is 1 minus P/3. Why is that? Because conditional on V equals 0, the order flow equals +1 is only possible if the informed trader is not present, which means the informed order flow is 0, and the noise trader buys 1 share. And as we mentioned above, it happens with probability 1 minus P/3. Conditional on V equals 0, if the informed trader is present, the total order flow cannot be +1, because when the informed trader is present, the informed trader is going to sell, and the total order flow cannot be +1. So now we have the probability of S equals +1 conditional on V equals 1, and probability S equals +1 conditional on V equals 0. We can calculate probability of V equals 1 conditional on S equals +1 using Bayes' rule, and the result is 1/2 minus P. That means the price conditional order flow being +1 is also 1/2 minus P, because it would just be 1/2 minus P times 1 plus the complementary probability times 0, which is 1/2 minus P. We can similarly calculate when the order flow equals 0, the price will be 1/2, and the order flow is -1, the price will be 1 minus P/2 minus P. So we can see here the bid-ask spread, which is the price when you have a buy order minus the price when you have a sell order, to be P/2 minus P, and that's positive. So the bid-ask spread, we can see that it's positive. The intuition is the same as before. There is information asymmetry between the market maker and the informed trader. This information asymmetry results in market maker price protects himself or herself. When a market maker observes order flow being +1, the market maker knows that it's more likely that it comes from informed trader buying. So the market maker is going to set P +1 to be higher than the prior mean 1/2. When the market maker observes order flow is -1, then the market maker knows that it comes very likely from the informed trader selling. So the market maker is going to price protect himself or herself and set P -1 to be smaller than prior mean 1/2. That's why P +1 is bigger than P -1, and we have the bid-ask spread. The bid-ask spread is increasing P, and P is the probability of informed trader being present, because higher P means that it's more likely that the informed trader is in the market. So that means there's more information asymmetry between the informed trader and market maker. So the bid-ask spread will be higher. And this is a theoretical justification for probability of informed trading as an empirical proxy for illiquidity. We're now going to show that more disclosure, reduce the bid-ask spread by reducing information asymmetry. Let's model disclosure as a binary signal Y that can be either H or L. And this Y is informative about V. The rest of the setup is the same as before. And let's assume that condition on V equals 1, the probability Y equals H is the same as condition on V equals 0, the probability Y equals L, some number Q that is between 1/2 and 1. That means condition on V equals 1. We're more likely to see Y equals H versus Y equals L, and vice versa, condition on V equals 0. The market maker now observes both the order flow and Y, the disclosed signal. So it sets price as a function of order flow and the disclosed signal. We also have a technical assumption. The informativeness of the signal Q is smaller than the probability that the informed trader will be present. This just makes sure that the public disclosure is not too informative, so that we still have the result that we observe. We can still show that the informed trader is going to choose to buy one share when observing V equals 1. It's going to choose sell one share when observing V equals 0, regardless of Y. And that's because the informed trader observes V, but Y is noisy about V. So they're not going to rely on Y. And we can similarly show using Bayes' rule the price as a function of order flow and realization of the public disclosure. And we can see that condition on the realization of public disclosure, regardless of whether the public disclosure is H or L, the bid-ask spread is going to decrease as a function of Q, which is the quality of the disclosed signal Y. So more precise signal reduces bid-ask spread. Now, this bid-ask spread may remind you of the famous Gloster-Milgram 1985 JFE paper. Their paper uses a similar trick. In our model, we assume that informed trader enters the market with some exogenous probability, but noise trader is always present. They assume that the order flow is always 1 or -1. However, it can come from either the informed trader or noisy trader. It just means either informed trader is present or noisy trader is present. And the informed trader either places order flow 1 or -1, depending on their information. But the noise trader places 1 or -1 randomly. And they assume that informed and noisy trader enter the market with some exogenous specified process. Their focus is on how bid-ask spread evolves over time. You can see that because of the information asymmetry, they have bid-ask spread. And they also show that when information asymmetry is very severe, the market breaks down. That just means bid-ask spread becomes sufficiently large and nobody is willing to trade. This would not arise in our model. This involves some tweak of liquidity traders' order flows. For more details, you can see their paper. So to conclude, discrete order Kyle model simplifies the algebra, allowing us to add more ingredients in the future, but it preserves the key intuition in models of trading with imperfect competition. Informed traders and the market maker have different information. Informed traders know more. It generates information asymmetry between the different parties. And that information asymmetry results in price protection from the market maker. And that's reflected in the bid-ask spread. More precise disclosure improves liquidity by reducing information asymmetry. It reduces bid-ask spread. In the next module, we're going to build on what we learned in this module. We're going to talk about feedback effect, how managers learn from the market, how managers glean information contained in the markets. If you want to test your understanding of this lesson, a review quiz of this lesson can be found at the following link. Thank you very much.